Yeah, I know, right? I like the videos though, but I don't have any videos for you. Okay, so I think and this is kind of what Mendeleev did as he organized the periodic table. You might think, well, they could just be random order, or they could just be, we know that we've been talking about atomic numbers. That's the red numbers on this periodic table. They're the whole numbers, number of protons in an atom of that type of element. We know that they increase by atomic number. But this law of periodicity, to me, I think it's very similar to a calendar. So if I was to put up a calendar, I might put Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. And for each day of the week, certain things come to mind. We do certain things. So I might say 1, 2, these are days of the month, 6, 7, and then I repeat. I'm back to Sunday again, and Mondays have a certain thing. Okay. So what we're going to see actually is the periodic table. The word periodic in periodic table means that, as it turns out, the physical properties of the elements are periodic. So it wraps back around. And so we're going to actually see these guys are like Monday or Sundays. These guys are like Mondays, okay? And these guys have some commonality. These guys, these guys, these guys, these guys. So that's what we mean by periodic. And what was known to Mendeleev at the time were certain physical properties of the metals. And then he kind of came back. He says, well, these are similar in this respect. These are similar in this respect. So I think that's pretty cool. So like I said, periodic table is arranged so that elements with similar chemical properties fall in the same vertical group. And actually the word group is one that we're going to use. Sometimes they're called families, but groups. Okay. So there's different aspects of the periodic table, but I call it kind of chunking up the periodic table that you need to be able to do. An important way to chunk up the periodic table is this jag right here. It's red here, and it's black actually. The other day I handed out periodic tables. This is the one you're going to have your test on Thursday. Okay, so it's black, that jag right there. That's very important. It separates the metals from the non-metals. And actually these guys down here are metals too. So metals, okay, non-metals. We only have a certain small amount of non-metals. Okay. Then along the jag are some folks that are kind of what we call metalloids. So they have kind of characteristics of being a metal and a non-metal. So they're called metalloids. And sometimes it depends on which chemist you talk to and what kind of mood they're in as to which. I've got 6 identified here, but it's a little suspect. Okay, so we're going to call these vertical columns groups. Okay, so kind of highlighting the groups. I go, and you're going to hear me go with the old convention, like that's 7B, these are all 8B, then we have 1B coming up. That's the old convention, and I can't break myself of that. 3A, 4A, 5A, those are groups. The newer convention, you see, I think it's a little less descriptive, is the number that goes across. Okay, so just so as you know, and just a while back, I finally came and put the old-timey convention, at least for the main group elements. So here I have 1A, 2A, it matches up there, 3A, 4A, 5A, 6A, 7A, and 8A. So speaking of main group, anything with an A is what we call main group elements. Okay, so you can see that not all main group elements are metals or non-metals, but how can we say this? All non-metals are main group elements, right? Okay. The B ones are what we call transition elements. So there's your B group. Okay. I'm going to talk about these guys here in a minute. Okay, so hold that thought. So we have groups going up and down, and we have periods going across. Now on the board, I don't have the period numbers. But the period numbers are marked on this one, so periods go across. And sometimes it's like playing a game. Like I might ask you, give me a metal that's in period 5. So you'd say period 5, and I pick any of these guys, and I would avoid antimony because he's right on the, okay, so metal in period 5. So again, there's no periods written up there, but there are periods written here. So, all right. So do you see where it goes? Atomic number 57. So 57 protons here, and then it goes to 72. Well, 57, and then you go to 58 across like that. Actually, those are called the lanthanide series. These elements down here are called the lanthanide series. They kind of insert in between 57 and 72. And then underneath them, we have actinide series. So, in other words, I think it said it on here, but can you see where, excuse me, the lanthanide series are in period 6, the actinide series are in period 7. So just make sure we're all on the same page there. So collectively, the lanthanide series and the actinide series are called the inner transition elements. So we have the regular transition elements here, sometimes called the transition metals. They're all metals. And then we have the inner transition metals or elements there. So there's a few that I want you to know a fancy name for. So collectively, group 1A elements are called the alkali metals. I get group 1A and 2A mixed up, but you can't, I can. Group 2A are called the alkaline earth metals. The way I remember alkali and alkaline earth is that 2A has kind of 2 words before the metals, and 1A has 1 word. So alkali, 1A, alkaline earth metals, 2A. So then where nitrogen is, we would call that, I would call it group 5A. Somewhat less descriptive, it's also group 15. These are called the pnictogens. So actually, it's only been since I've been using OpenStax that I've said, oh, group 5A are the pnictogens. So, and then next to it, group 6A, they actually are the chalcogens. There you go. But 7A gets back to something that I am, bless you, have been doing for years. 7A, collectively, those are called the halogens, and you might recognize that name as one that's used in light bulbs. So those are the halogens. And then 8A goes by 3 names as far as I can tell. So 8A, they go by rare gases because they're relatively rare. They go by inert gases because they don't like to make bonds with other things. And they go by noble gases. I think it's the same thing because they're rare. So those 3 names all are 8A elements. So you had this slide before that actually tells you which ones, I'm telling you this at the beginning of the semester and it kind of carries through. Like if I put, if I spell out the name iron, you're gonna maybe have to find iron on the periodic table. So for all of these, and that's atomic number 26, so you can see that's between 24 and 30, I am gonna count on you knowing. So to go back and forth between the symbol and the name. Okay, so we've been talking about physical properties and chemical properties, intensive and extensive properties. So here are some just physical properties. No metal is destroyed in measuring these. But in general, we can take the JAG and we can say with regard to conductivity, specifically conductivity of electricity or thermal energy, metals tend to be pretty conductive. Non-metals, not so much. Okay. With regard to it being shiny, lustrous, okay, you would tell me that metals tend to be shiny, and that's true. And non-metals are generally dull. With regard to, now the next 2 kind of go together. Malleable means that I can make it into a sheet, and ductile means that I can pull it out into a wire. And if you can picture a piece of carbon, like your pencil lead, I don't think you're going to make it into a sheet or make it into a wire. So nonmetals generally are not malleable nor are they can we draw them into wire. Metals, yeah, in general. All right, what else we got? Okay. So I just kind of have throwing out some things with regard to all of those elements. There's just a handful of gases. You might recognize some of those are in our Hofbräu nickel. Because remember we said that the 7 diatomic elements, you have to make them into a little molecule. There's always going to be like 2 atoms of hydrogen stuck together, etc. What's missing there looks like is bromine and iodine. I think it's 5. So speaking of bromine, it's one of the few liquids. Isn't that not weird? Okay, now it's not to say that you cannot liquefy things, because you can. You can take a solid and liquefy it by heating it up. But under normal temperatures on Earth, temperatures and pressures, you only have 2 liquids. And then everything else is a solid. Then just got some pictures here, some elements. Notice this is a little dated, 113, or are we up to 118 now? Some pictures. This is bromine, one of the few, only 2 liquids. And iodine is just really nasty about what we say subliming. So if you see this purple haze here, in its natural state, iodine is a solid, but it breaks its bonds and it skips the liquid stage and goes right to a gas. So that's kind of crazy. All right, so then this chapter will be due, we decided on this. So collectively, do you want to look at something or?
Yes.
I want to look at numbers.
I have.
Okay, Maddie.
5.
2, 4, and 5. That's like everything.
Struggling.
All right.
The rest of them.
I guarantee you're overthinking number 2.